Hello everyone. In this video, we will study one sorting technique, that is bubble sort. So this is one of the simple sorting technique where a given list of elements which are not in sorted order, by using bubble sort we can sort that elements. So here first we will compare the first element with second element, and suppose if the first element is greater than second element, then exchange the elements. And suppose if the first element is less than second element, then don't change the position of that elements. So if the first element is greater than second element, then we have to change the position of the elements. So after doing that, go for the next adjacent elements, that is second and third element, and compare these two elements. So that is second element is compared with the third element. And suppose if the second element is greater than third element, exchange the elements. And suppose if second element is less than third element, then keep those elements as it is. So like that, till the last element we have to compare the adjacent elements continuously, and at the end we will get the maximum position at the last position in the unsorted list. So in this way, by finding in the each pass the maximum element, finally we will get the unsorted list in the sorted order. So to understand this concept easily, we will take one example and we will see how bubble sort can be implemented on unsorted list. So suppose these are the given list of elements which are in unsorted order, that is 12, 6, 7, 10, 27, 18, 23, 77, 29 and 3. So by applying bubble sort technique, we can sort these elements. So as per bubble sort, first we have to compare the first element with the second element, and after comparing, if the first element is greater than second element, then exchange the position of elements. So here 12 is greater than 6, that means we have to change the position of these two elements. So 12 will goes to the second position and 6 will come to the first position. So after exchanging these two elements, we have to go for the next two adjacent elements, that is present at the second position and third position. So 12 will be compared with 7. So is 12 is greater than 7? Yes, the condition is true. That means again we have to exchange the elements. So 7 will come to the second position and 12 will go to the third position. So next, go for the next two adjacent elements, that is 12 and 10. So here also 12 is greater than 10, that means we have to change the position. So 10 will come to the third position and 12 will goes to the fourth position. So the next two adjacent elements are 12 and 27. So compare these two elements. So here 12 is not greater than 27. That means these two elements will remain as it is, and we will go to compare the next two adjacent elements. So 27 will be compared with 18. So 27 is greater than 18. That means we have to exchange the elements. So after exchanging, go for the next two adjacent elements, that is 27 and 23. So 27 is greater than 23. Yes, the condition is true. So we will exchange the elements. So the next two elements are 27 and 77. So here 27 is not greater than 77. So these two elements will remain as it is. So go for the next two adjacent elements to compare, that is 77 and 29. So here 77 is greater than 29, that means we have to exchange the elements. So after exchanging, the next two adjacent elements are 77 and 3. So here 77 is greater than 3, that means we have to exchange the elements. So 3 will come to the ninth position and 77 will go to the last position. So now you can see, after comparing all the elements, at the last we have got the maximum element, and that will be positioned at the last position in the sorted list. So after comparing adjacent elements 9 times, because there are 10 elements, so we required 9 comparison to get the maximum element in the list. So in this way we can get the next maximum element, but here there are 9 elements which are unsorted in the list because 10th element is already sorted. So because there are 9 elements, we require 8 comparison in the next step to get the second maximum element. So again repeat the same steps which we have repeated previously. So first compare the first element with the second element. So 6 is greater than 7. No, the condition is false. That means the elements will remain as it is. So go for the next two adjacent elements, 7 and 10. So here also 7 is not greater than 10. So go for the next two elements. So 10 is greater than 12. No, again the condition is false. So go for the next two elements. So 12 is greater than 18. No, again condition is false. So go for the next two elements. So is 18 is greater than 23? No, again the condition is false. So next two adjacent elements are 23 and 27. So again the condition is false. So go for the next two elements. So is 27 is greater than 29? No, again the condition is false. So the elements will remain as it is. So go for the next two elements, that is adjacent elements, 29 and 3. So here 29 is greater than 3. So the condition is true. That means we have to exchange the elements. So 3 will come to the 8th position and 29 will go to the last position. So we have compared here 9 times because the last element is already sorted, that is 77. So we don't need to compare that element because that element is already sorted. So in the second pass we have got the second maximum element and that is placed at the 9th position. So after second pass we have got the two elements which are in sorted order. So similarly we will repeat the same steps to get the third maximum element. So here again compare first element with second element. So is 6 is greater than 7? No, the condition is false. So go for the next two adjacent elements. So is 7 is greater than 10? No, again the condition is false. So go for the next two adjacent elements. So is 10 is greater than 12? No, again the condition is false. So next two adjacent elements are 12 and 18. So is 12 is greater than 18? No. Again the condition is false. So next two elements are 18 and 23. So is 18 is greater than 23? No. Again the condition is false. Next two adjacent elements are 23 and 27. So is 23 is greater than 27? No. So the next two elements are 27 and 3. So 27 is greater than 3. Yes, the condition is true. That means we have to exchange the elements. So 3 will come to the 7th position and 27 will go to the 8th position. So after 7 comparison, we have got the third maximum element and which is on 8th position. So after third pass, we will get the third maximum element which is in sorted order. So after 3 pass, we have got the 3 maximum numbers which are in sorted order. Again repeat the same process for remaining unsorted elements. So first element will be compared with second. So 6 is greater than 7, which is false. So go for the next two comparisons. So 7 is greater than 10. Again the condition is false. So go for the next two adjacent elements. So 10 is greater than 12. No. Again the condition is false. So the next two elements are 12 and 18. So 12 is greater than 18. No. Again the condition is false. So the next two elements are 18 and 23. So again 18 is not greater than 23. So the next two elements are 23 and 3. So 23 is greater than 3. Yes, the condition is true. So we have to exchange the elements. So 3 will come to the 6th position and 23 will go to the 7th position. So in this pass, we required 6 comparison to get the 4th maximum element. So after that, we have got the first 4 maximum elements and which are in sorted order. Similarly, repeat the same process for 6 unsorted elements in the list. So take first two elements, that is 6 and 7. So 6 is greater than 7. No. Next two adjacent elements are 7 and 10. 7 is greater than 10. Again no, the condition is false. Next two elements are 10 and 12. 10 is greater than 12. No. Again the condition is false. The next two adjacent elements are 12 and 18. So 12 is greater than 18, which is false. So the next two adjacent elements are 18 and 3. So 18 is greater than 3. Yes, the condition is true. So we have to exchange the elements. So 3 will come to the 5th position and 18 will go to the 6th position. So after comparing 6 adjacent element, we will get the 5th maximum element in the sorted list. So these 5 elements, that is maximum 5 elements, are in sorted order. So now do the same task to remaining 5 unsorted elements. So first again consider two adjacent elements, that is starting adjacent elements, and compare. 6 is greater than 7. No. Go for the next two adjacent elements. Is 7 is greater than 10. Again the condition is false. So go for the next two adjacent elements. So 10 is greater than 12. No. Again the condition is false. So go for the next two adjacent elements. So 12 is greater than 3. Yes, the condition is true. So exchange the elements. So 3 will go to the 4th position and 12 will go to the 5th position. So now we have got the 6th maximum element from the given list, and it will be sorted in sorted list. So now we have got 4 elements which are not in sorted order. So do the same steps again compare the first element with second. So 6 is greater than 7, no, so go for the next two adjacent elements. So 7 is greater than 10, again the condition is false, so go for the next two adjacent elements. So 10 is greater than 3, yes, the condition is true, so we have to exchange the elements. So 3 will go to the third position and 12 will move to the fourth position. So this will be our next element in the sorted list. So now again repeat for the last remaining 3 elements. So compare first element with second element. So 6 is greater than 7, no, the condition is false, so go for the next two adjacent elements. So 7 is greater than 3, yes, the condition is true, so just exchange the elements. So 3 will go to the second position, and 7 will move to the third position. So next element will be in sorted order is 7, that is the 8th maximum element. So now we have just 2 elements remaining. Apply the same technique, compare the 2 adjacent elements. So if 6 is greater than 3, yes, the condition is true, so we have to exchange the elements. So 3 will come to the 6th position and 3 will come to the first position and 6 will move to the second position. So now there is only one element remaining, and which is automatically in sorted order. So in this way, by applying bubble sort, we can easily sort the given elements which are not in sorted order.